Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Right, we are going to do some questions on conservation of energy. So in this question, we have a trolley that runs from P all the way to Q. Now they already told you the PE at Q is 50 kilojoules less than at P. And they also gave you the KE at P. And there's also work done against friction. So what is the KE at Q? Now there are two ways to solve this. But I think the easiest way is to use conservation of energy in this form. Now, conservation of energy means when there's a loss in energy in one form, it must surely be converted to another form. So it becomes gain in energy in another form. So let's talk about moving from here all the way to here. So therefore, when it moves from here to here, it obviously loses GPE because the height of P is more than the height of Q. So there will definitely be loss in GPE. But what will this GPE become? So obviously it's going to become gain in KE. So you can equals to gain in KE. But there's also heat loss due to friction because there's work done against frictional force. So where should we put it? Is it here or here? So if you think about it, heat comes as a byproduct after the whole movement. So you must put on the right hand side. Because what is used is on the left hand side, what is produced is on the right hand side. So heat is produced, so you put it on the right hand side. So when we say loss in GPE, they already told us that the PE at Q is 50 kilojoules less than at P. So the loss in GPE will be 50. Now the gain in KE, now obviously the KE here is going to be bigger than the KE here. So you're going to take KE at Q, subtract the KE at P. Now heat loss due to friction will be 10. So now you substitute the KE of P as 5 kilojoules inside here, alright, and then you can bring this and this over and they can find the KE at Q. But there's a second way. If you don't want to do this method, you can also do conservation of energy in this form. That is, all the energy here must be equals to all the energy here plus whatever heat is lost. So what energy do you have here? You have KE at P and the PE at P. And then what do you have here? You have KE at Q and PE of Q plus heat loss at the end. So now you can substitute whatever you have into the equation. Alright, but before you do that, you might want to make KE or at Q as a subject first. So you bring the rest of it over. So then you can substitute the KE of P as 5. Now you can take the PE of P minus the PE of Q at PE at Q as one term because you don't know specifically how much, but you know the difference. So you label this as 50, and then the heat loss you label as 10, and you should be able to get the KEL at Q to be 45 to be the same. So whichever method you prefer is fine. In our next question, we will talk about conservation energy that involves interconnected objects. So in this question, what we have is a lift system whereby the elevator, which is this, is partly counterbalanced by the heavy mass. So at what rate does the motor provide energy to the system when the elevator is rising at steady speed? So what we have to do here, again, we can use the conservation of energy like previously. What energy is lost will become what energy is gained. So in this case here, this mass is obviously, M2 is obviously going down, so it will definitely lose GPE. And this mass is obviously going up, so it's gaining GPE. But what about the work done by the motor? Where do I add it to? I already told you on the left hand side is the input or what you use, and the right hand side is what you produce or the output. So therefore, your work done by the motor is used to lift this as well. So you must put it on the left hand side because it is a work done by the motor which is part of the input together with the loss in GPE, and together it becomes the gain in GPE of the elevator. So by writing the equation in terms of energy first, we have to convert to power, because when they say rate that it provides energy, it is actually power. So you need to divide by time. So how do you divide by time? Each one is divisible by time. So this becomes the power provided by the motor, or the rate at which a motor provides energy. So this will be the rate of loss of GPE. This will be the rate of gain of GPE. So remember, we want to find this, so let's call the work done over time as our subject. So we bring this over. Now the gain in GPE of M1 will be M1 GH over T. You bring this over, the loss in GPE of M2 will be M2 GH, then you divide by time. So you will notice that H is actually the change in height, which is the distance traveled over time, so that is speed. This is also change in height over time, so that is speed. So basically you can change this to V and change this to V. So you get M1 GV minus M2 GV. Now some people ask me, why didn't I consider kinetic energy? It's because it's rising at steady speed, that means your KE is constant. So therefore, there's no change in KE. For the next question, this is actually a conservation of energy regarding the work done and also the change in KE. So we can write down the equation, which is work done equals to change in KE, because we want the expression of force and distance, which we can convert this to force times distance. And the change in KE, do not convert, leave it like this, do not change to half mv squared, because they only want the final KE. So using this equation, we can use the ratio method. So therefore, we can say the change in KE2 over the change in KE1 will be F2 D2 over F1 D1. So then you can find the new change in KE by taking the ratio of F2 over F1, which is F2 is 2F and F1 is F, so the ratio is 2. D2 is 2S, D1 will be S, so the ratio is also 2. And then finally, you can bring the change in KE1 over, so the change is 4 to 8, so the difference is 4. So you get the change in KE of 16. But you need to understand, this is not the final answer. We don't want to find the change in KE, we want to find the final KE right here, original KE become. So since the original KE is 4, there's a change of 16, so you plus 16, so you get the answer of 20. Now this question, there's a solid rubber ball, diameter is given. Now if it's released from rest and it falls vertically and then bounces back up, so we have to find what is the KE after it leaves the surface if the KE just before it strikes is 0.75. So you can see that this is actually a ratio question as well. So moving from here to here, what energy is lost? GPE. What energy is gained? Is KE. Then when it moves back up, there will again be gain in GPE and there will be loss in KE. So in other words, from here to here or here to here, there's a change in KE and GPE involved. So I will just write down the change in KE equals to change in GPE. But there will be a need to change the expression of change in GPE to mgh, because what is given to us is the height of the ball. So let's do the ratio method now. mg is constant, so no need to write it down. So basically, the change in KE2 over the change in KE1 will therefore be H2 over H1, because mg is a constant. So what is your change in KE2? That means moving from here to here. Change of KE1 is from here to here. So now I just want to also tell you, why am I using change in KE but I never put the delta anymore? Because moving from here to here, the initial KE is 0, the final KE, let's say, is E1. So the change in KE is E1 minus 0. So it's basically just E1. Similarly, moving from here to here, the initial KE is E2, the final KE here is 0. So the change in KE is E2. Now you don't have to take initial minus final or final minus initial purposely, because when you use the word change, it's just the magnitude. So you take the bigger minus the smaller. Like for example, moving from here to here, this side has more KE in here, so I take E1 minus 0. Moving from here to here, this side has more KE than here because it's 0, so I take E2 minus 0. So that's why I don't have to put the change in KE there. So what is my H2 and H1? You also need to be careful because of the diameter of the ball. When the ball hits the floor, what is the distance traveled? Now, if you take the top of the ball as a reference, now remember I said if the shape or orientation of the object doesn't change, you can take the height change of the top or center or bottom, it doesn't matter. You take from top to top, even though it falls a distance of 80, but that is the top falling to this point here. So the distance fallen by the top is not 80. You need to take 80, subtract the diameter, which is 8. So this is 72. So H1 is actually 72. Similarly, when the ball goes up here, even though the height here is 45, so from the top to top, you only went up by 45 minus 8, which is 37. So you need to substitute H2 as 37 and bring the E1 over, which I told you is 0.75, and you will get the final KE, which is 0.39. In this question also, there's a conservation of energy because a small mass is placed at P. Now it is then released from rest, and then it reaches point T, all right, with a speed of 4 meters per second. So you will notice that along the way, the speeds are also given. So they told you that the mass loses a potential energy of E when it moves from here to here. So at which point will the mass lose E over 4? Which of these points? Now obviously, it will be at a higher point because it did not lose as much energy as before. So the conservation of energy I would use here is, since they talk about losing GPE, and since they gave me the speed here, I would say that the loss in GPE will be the gain in KE here. Now, if you want to use the ratio method, also possible, because let's say the loss in GPE is E, and the gain in KE is half mv squared minus 0, because you start from rest. So I can omit the minus 0 here. So then I can use the ratio, because half m again is a constant. So E2 over E1 is V2 squared over V1 squared. Now what is my initial situation or scenario they gave me? If it loses energy of E, so means if E1 is E, the speed will be 4 because it reaches T. So if it loses E over 4, what will be the speed? So I'm going to find the speed first, then I will know whether it's at Q, R, or S. So let's substitute. Now E2 will be 1 over 4E, and E1 will be E, so the ratio will be 1 over 4. V2 squared is what you want to find. So V1 squared is the speed here, 4 squared. So therefore, you will get an answer of V2 will give you 2. So if V2 is 2, it's basically at this point. So the answer will be boy. This question is related to projectile motion. Alright, so when the projectile is launched at 45 degrees with initial KEE, so probably we can draw it out. So let's say this is the horizontal, this is 45 degrees. So you're launching it at the speed V, which we don't know how much, but we do know the KE is E. Now, what will be the KE at the highest point? Now, to find this, we can use the ratio method as well, because KE will be half mv squared. Now, when it reaches the highest point, what is its speed? Because whenever we use the formula half mv squared, the v here must represent the resultant speed, not the horizontal, not the vertical, but the resultant speed. Like for example, if you project the ball at 45 degrees with speed v, so v is the resultant speed, so you use this v to find the ke, not the v cos 45, not the v sin 45. So when it reaches here, what is the resultant speed? Now remember, at the highest point, the vertical speed will drop to 0, so you only have a horizontal speed. But we do know the horizontal speed here is the same everywhere because the horizontal speed is constant. So if you remember, to find the horizontal speed initially, it will be v cos 45. So when it reaches the highest point, the horizontal speed will still remain at v cos 45. And so happens that this horizontal speed will become the resultant speed of the ball at the highest point because there's no vertical speed. So your horizontal is your resultant. So using the ratio method, E2 over E1. Now half m is constant, so you don't need to write it down. So it's V2 squared over V1 squared. So your E2, now remember your V2 is your new speed, so it's V cos 45. Don't forget to square it over the original speed square. Then this will be over E1. So therefore E2, now the V squared on top here, when you square it and the V squared will cancel, so basically you're going to get cos 45 squared. And cos 45 squared is actually equals to half. right? Then you bring the E1 over, which is E, so the answer will be 0.5 E, which gives you an answer of A.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.